Hi, welcome to Parametric House. In this tutorial, I want to show you how you can make this parametric tower by defining the height, how many rotations, the different rotations you can create at the top, middle, and bottom, like this. You can also create different dimensions for the bottom, middle, and top, or you can randomize it, obviously. We can also control the number of panels here, which I'm going to explain, which is just for visualization. And we have a control over the shape of the building by just changing a point. So you can see that we can change that. Change the tower. And we can also define how many sections we want. We're going to talk about that and create the floors. Also, at the end of this tutorial, I'm going to use the Galapagos to create random results. This is a good way of creating random results by changing the tower rotation and dimension. And good thing about this is that you can also stop this after it has run for one step, which is 100 solutions. And as you can see here, we can select between this randomize suggestion from Galapagos, which is also useful. Maybe you want to use that one for your design and then make this a little bit smaller. Okay, for example, you want to make this one as this results. So you can use this tutorial to learn how to make this step by step, and let's get started from scratch. Okay, first of all, we want to create a tower, so we can define 2 points from the params menu. And I'm going to also put this to full names. Right click and set multiple points. Use the control key to bring it up. And these 2 points are going to be helpful to create the tower I want. We can go to the curve and use a polyline to create a polyline from these 2 points. And we have that here. Because I want to define 3 sections, which is going to be somehow a rectangle with Nurbs curve, I'm going to go to the analyzers and use this perpendicular frame to create the frames. This is a good way if you want to define the frame on this curve. So if I right click and reparameterize it and give a number slider between 0 and 1, especially that we reparameterize it, this is going to be the location. So here you can say, for example, 0, 0.5, and 1 for this bottom, middle, and the end. Instead of that, we can also use another tool in the curve, divisions, and that is perpendicular frames. So we can say, okay, I want to create only 3 counts. Okay, instead we need 2 because we need this top, bottom, and middle. Whatever number you give that, it's going to be increased by 1. So we can say that we need only 2 to get the frames we need. And now we have the frames. For example, if I put them into a frame container, you can see that we have it here. Okay. Now, what I want to do is to create a rectangle. So let's go to the curve, primitive, and work with the rectangle part. The plane is obvious. We need a X size and a Y size. And as you can see here, the input is a domain. That means that whatever number you can give, it's going to be from minus to plus, okay? And because we want to make that rectangle at the center, obviously, whatever length you want is going to be from minus x divided by 2 to x divided by 2. So you always have the length x. We can create that by going to the math and using a domain. And for the domain start and end, I'm going to say I'm going to use one number. So params menu, a number. And we're going to give that to here. Expression, minus x divided by 2. And expression x divided by 2. That is going to create a rectangle based on a length I want. So for example, I can say from 10 to 40 with 2 decimals. And I can say length. Okay. If you want to even have bigger numbers, you can increase the sliders. Let's Control-C, Control-V that and use that for the Y size. Okay. So if I want to randomize the length, I can just delete these two sliders, go to the parameters menu and use this gene pool. The good thing about gene pool is that you can right click and randomize it to create random numbers. Double click it. We need 3 sliders because we have 3 sections. We want to be from maybe 20 to 100. And we can make that smaller and give that to the size X. And another one for the size Y of the rectangle. So if I randomize that, you can see that we can create more control over the dimension of the rectangle. Okay, before we create that, we can also rotate these planes. And we can do that by going to the vector and plane section, which is obviously related to plane. And we can use this rotate plane to create that rotation, because whatever plane you have, it's going to rotate it based on the Z direction of that plane. And because it's going to rotate it around Z, we can create somehow rotation of the sections. So we can say, okay, rotate plane. And right click, instead of radians, we can degrees for the angle. And now we can create another gene pool sliders, 3, and between 0 and 90 degrees, for example. Okay. And you can see that's going to rotate the first one, the second one, and the last one. And we can randomize that too to create this kind of sections here. Okay. If I want to create the tower, obviously creating a surface loft is going to make something like that for you. Or another thing you can use is the fit loft. It's going to make it towards that loft here, but as you can see, it's not really what we want. Because I want to make this smooth, and we can practice some more tools here. Let's go to curve and use this continuity to create the point corners of this rectangle. Okay, so we have that. As you can see here, we have 3 groups of 4. If I simplify that, and let's give this a param viewer so you can see it. As you can see here, this is, for example, the first rectangle. So it's called bracket 0. That's the first group. And it has 4 corners. 1, 2, 3, 4. And then it goes to the second group. So as you can see here, we have branches of 3 groups of 4 corners. Now we can use that to create a Nurbs curve, spline, and I'm going to use this Nurbs curve component. Give that to here. If you want to, you can use this, but we won't close that. But for example, if I want to use a surface loft, as you can see here, nothing is going to be created because each of those curves are in separate groups. So we have to flatten this. So we have a group of 0 and n equals to 3, right? We're going to explode all of those groups into 1. So flatten. I think that's also interesting way of creating a tower like that. Or maybe you want to create a facade, something like this. So for example, if I have this facade and I take a point and, for example, click here, we can make a bounding box from that. So it's a bounding box, something like that. And then explode the bounding box and delete these facades. And then we can use that to create the building. For example, I can extrude that here. Extrude this a little bit forward. And then we can trim it. So let's go to trim. Trim this extra parts. And then we can just join them together and cap that. Okay. So as you can see here, you can create this building in Grasshopper easily. Okay. To create this kind of thing in Grasshopper, it's going to be a little bit complicated, but if we want to, we can create a point. Set one point and put it here. Then we can go to the surface, create bounding box, use the shift key to add it to here, check if it's in one group, and right click and make a union box. Okay, so that is going to be the united box of this. And by moving this point, you can make the building a little bit bigger and control it easily. Okay, after that, we can explode this bounding box and only select the faces we want. So for example, the faces we need here. Obviously we have 6, so we can say from 0 to 5, and let's select the faces we want. This one, and this one, for example. Okay. Now what we want to do is to go to this loft, surface, brep edges. Maybe we can extract the edges. We have the naked edges here. And let's pick these two curves. So I'm going to select this one and this one. Okay. So we have this curve and this curve as an output. Now what we have to do is to just project it onto this plane. So if we want to, we can go to transform, project onto a plane, project this curve into, I have to make this separate. So I'm going to say one of them is 1 and one of them is 2. Okay. So we're going to project this one into this plane. We have it here. And we can use the surface loft. Use the shift key to add them together. Okay. And again, we can project this curve into this plane and actually loft them together. This curve and the projection shift key. And that's all we want. We can join these together. Brep join. Use the shift key to add this one to this one and this one, and be sure that it's flattened, because as you can see here, these two groups are not added together. So I'm going to flatten that. Have it here. Turn everything off. Have this as a building. I think that's really cool. And you can also, before we finish it, control that with these rotations. Dimensions. Like that. Okay, to finish this, we need, I think that we have this point at this corner. So we have to project that into a plane we have here. Let's do that. This is the projection of this one. And we have another projection here. Let's work with these two and project them. So transform, project into a plane. This one has to be projected on a plane of X, Z plane on this point. So why not just make an XZ plane, XZ plane, and give that to the point we have here. Okay, and we can lock that. And another one is going to be a YZ plane. YZ plane for this one to be projected. So I'm going to say YZ plane of that point and project it. And make this a loft. Okay. Now again, we can use the brep join and join, or we can just bring this brep join here and add these things to it. Shift key to add it up. And we have it here. And let's just cap this. Now that we have this, we can also use a custom preview to see that here. And you can have that if you want to create the sections. You can say intersection mathematical contour. Create a contour for the shape. The point is going to be the same point we had here. Remember that changing this point is going to change the tower easily. And then we can create the direction of Z and the amount you want. For the amount, we can say, let's see the length of this polyline because this is the height. So I can just create a number for that and bring it here. And we can say math divided by whatever section you want. So maybe 3 to 20. As you can see here, the last one is missing. So I'm going to create this distance a little bit smaller. X minus 0.001. So it gets also the top. And that will give you the sections if you want to. So if I delete everything, change it, turn it off, you can see that here. And if you want to see the facade, we can turn this on. The good thing about this is that it's a Nurbs curve. So if you want to, you can use the Launchbox plugin, maybe create a panel on it. For example, quad panels. And define how many UV divisions you want. So for example, 3 to 12. And increase or decrease that number of divisions here. So you have that here. As a window, you can also use the Launchbox plugin. A frame, I think it's in here, generate frame, to give it a smaller frame. Okay. And then you can just give this a custom preview. So let's display custom preview, one for the frame, one for the windows, and just give it a swatch blue, and another one for maybe facade white. And you can also use the brep edges always to see the naked edges. Okay, just for preview, I think that's fine. And we're going to go here and create the parts of it we want for the facade. If you want to have them separately, obviously we can just give a custom preview to them here. So I'm going to say this was here with a shift key. Add this one. Add these two also. And if you want the top or bottom, you can obviously go for the contours, flatten that, and pick up with a list item the first one and zoom in and hit plus to go at the end, the last one. Okay. Use the shift key to just see them with a custom preview. And have it a swatch to see it inside, maybe a little bit. like that, and see the surfaces inside with another color, maybe yellow. Okay, just to show you that you can have them separately. Like this. Okay. So that is going to give you the building, the tower, and now we can play around with all of these. Randomize the rotation. Randomize the dimension if you want to. And if you want to just see the different results you want to get, just to have them, you can go to the parameters menu and pick up the Galapagos. Give it to these gene pools, use the shift key. And for the fitness, I'm going to make a random number. For that, we can, because we have to define a fitness, I'm going to say a number to that. Mass addition, add all of them up. Use the shift key to add all of these numbers so they are completely random. And we give that to the result. That is going to be a random number added up. So we just give that to the fitness. And now we can just say, okay, the minimizers, maximizers is not important, but we can say we want 100 different results for that. Just put that to the display all genomes, and you can see it's going to run and create this different buildings of this. If I stop it, because it's completely random, we can go to the first stage, and each of these are different suggestions of randomized solution. So you can just reinstate it, and see different results. Obviously, these are completely random. And for example, I want to have this one here. Okay. That's how we can make this parametric building. I hope this tutorial was useful. You can download this example file from parametrichouse.com, and see you next time. Bye. Remember that you can download these example files all from our website, parametrichouse.com. And remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.